A 500 Newton block is resting on an incline and is subjected to a force of 600 newtons acting parallel to the inclined plane. After the block has moved 3 meters from rest along the inclined plane, the force 600 newtons is removed. The inclined plane has a slope of 3 vertical to 4 horizontal, given a coefficient of friction equal to 0.20. We are tasked to find the distance that the block will move farther along the incline until it will stop, and we are tasked to compute the velocity and acceleration of the block when the force of 600 newtons was removed. To solve this problem, let's try to draw our figure. So we have an inclined plane that has a slope of 3 vertical and 4 horizontal with an angle theta right here, which is also equal to this angle. We can solve for theta using the arctangent function. We have the opposite side of 3 meters divided by the adjacent side. We get our theta equal to 36.87 degrees. And then we have our 500 Newton block. We can get the mass by dividing the weight by its gravitational acceleration. We get mass equal to 500 newtons divided by 9.81 meters per second squared. So the mass of the block is just equal to 50.97 kilograms. So let's say we have our block here. There is a mass m, and it is subjected to a force of 600 newtons going upward. And due to its own weight, it also exerts a force going down that has a value of 500 newton, which is its weight, times the sine of theta. Also, due to the frictional force at the surface, there is a coefficient of friction of 0.2, which will also tend to slow down the motion of the block. That has a value of the weight of the block, or normal force, that is a value of 500 cosine of theta multiplied by the coefficient of friction of 0.2. And that is the frictional force induced on the surface of the block. That is equal to mu times the normal force of 500 Newton cosine theta. Now, due to these forces, it will tend to induce a net force of the block going downward with a value of mass times the acceleration. Taking summation force parallel to the surface equal to mass times the acceleration, taking upward forces to be positive, we have our 600 Newton force going up minus the 500 Newton force going down, sine of theta, that is 36.87 degrees, minus the frictional force of 0.2 times 500 newtons cosine of 36.87 degrees, equal to mass times the acceleration, which is positive because it's going upwards. And we are given a mass of the block that is equal to 50.97 kilograms times the acceleration that we want to solve. So we have 600 minus 500 sine of 36.87 degrees minus 0.2 times 500 cosine of 36.87 degrees equal to 50.97 times the acceleration. We get A equal to 4.32 meters per second squared. And that is our net acceleration. Now we can proceed solving for the distance that the block will move farther along the incline until it will stop. And after some time, this block here will move 3 meters from rest along the inclined plane. Let's say it will move right here, and it will have a velocity that is equal to v sub b. We can solve this using the equation in kinematics given the initial velocity and acceleration and the distance, that is v sub f squared equal to v sub I squared plus 2ed. We can solve for v sub f, that is basically v sub v squared equal to the initial velocity of 0 plus twice the acceleration of 4.32 meters per second squared times the distance of 3 meters. We can solve for the velocity. equal to square root of 2 times 4.32 times 3. That is equal to 5.09 meters per second. Now that we have our velocity of the block after it has moved 3 meters from rest along the inclined plane, the force 600 Newton is now removed, which means that only the frictional force of 0.2 500 cosine theta and the force due to its own weight of 500 Newton sine theta would be acted on this block, which would tend to decrease the velocity or pull down the block downward, which means that after some time, this block here would stop at some point farther along the inclined plane. Let's call this point point C, which has a velocity of 0, since it will stop. Now to solve for the distance that the block will move farther along the inclined plane until it will stop, we will use the formula in kinematics given the initial and final velocity and the acceleration, that is Vf squared equal to Vi squared plus 2AD. We have our final velocity equal to 0 and the initial velocity of 5.09 meters per second squared plus 2 times an acceleration that is equal to the frictional and force due to its own weight of 0.2 times 500 cosine of 36.87 degrees plus the force of 500 sine of 36.87 degrees. Since it is in terms of newtons, we divide this by mass of 50.97 kilograms to convert this into acceleration. And since the acceleration would tend to decrease the velocity of the block, which means that it will tend to decelerate the motion of the block, which means the sign for the acceleration is negative. And then we multiply this by the distance d. And we can solve this using our calculator. We have 0 equal to 5.09 squared plus 2 times negative of 0.2 times 500 cosine of 36.87 degrees plus 500 sine of 36.87 degrees divided by a mass of 50.37 to convert this into acceleration. Multiply this by distance d that we need to solve. We get d equal to 1.74 meters. And for the last problem, once the 600 Newton force was removed, only the force due to friction and due to its own weight would act on the block that has a value of 0.2 500 newtons cosine of theta plus 500 newtons times sine of theta. To convert this into acceleration, we divide this by a mass of 50.87 kilogram. So we have our acceleration that is equal to 0.2 times 500 times cosine of 36.87 degrees plus 500 sine of 36.87 degrees divided by 50.97. We get our acceleration equal to 7.46 meters per second squared. So for the first problem, the distance traveled by the block along the inclined plane until it will stop, that is equal to 1.74 meters. And the velocity of the block when the force 600 Newton was removed, that is equal to 5.09 meters per second. And the acceleration of the block when the force 600 Newton was removed, that is equal to 7.46 meters per second squared. And these are our final answers.